Hello everyone, this side Priya Bhatia. I hope you all are doing well. So, in this video, we will be talking about the interview questions which are very widely asked with respect to machine learning per se. So, if there is anyone who is willing to, go for the interviews with respect to machine learning, so I believe that if you will watch these videos, which covers up the top 25 questions very widely asked in an interviews, you will be, get a more confidence with respect to the interview, and there are very high chances that these questions can be asked from you as well. So here I am sharing my own experiences when I was applying for data science positions. Whatever questions have been asked from me, all those questions I have tried to cover up in this complete video. Please make sure that you hit like button, you share these videos with each and everyone, because designing these kind of videos takes a lot of time, lot of effort, lot of energy, and these things will be really helpful and fruitful with respect to me if I will be able to reach to more wider audience, and that will be only happen if you will support me on this particular task, right? So without wasting any time, please make sure that you will watch this video till the very end. It might be a very long video, so please try to watch it. I will try to attach the timestamps in the description of this video, so you can just check it out, whatever questions I'm covering up in this video. And please make sure that you will watch till the very end to get the better understanding and to get the better advantage of this complete video. So in this particular video, I will talk about the interview-based questions related to data science. So what are the vastly asked questions which can be asked from you as well whenever you are going for an interview, right? So the very first question which is coming into my head is this. Please pay attention towards this session, and I hope that the session would be pretty much useful for everyone. So the first question is that the binary classification problem is given to you. Okay, so the interviewer is saying to you that they have been provided a data which is responsible for a binary classification task. Binary classification task. Okay, so I hope everyone knows what is the meaning of a binary classification. Suppose, let me give you one example with the help of which you will be easily able to understand the concept. The simple meaning is that suppose you want to do a diabetes prediction. You want to do a diabetes prediction, that whether a person is diabetic or not. That is the simple thing that you need to do. Now, here the outcome is either 0 or 1. So whenever we are talking about diabetes prediction, we are taking a outcome column. Now this can be either 0 or this can be either 1. Simple. Now, what is the question they are saying is that when you are performing this task, you observe that there is one problem in this particular data set. What is that problem? That the person or the people who are not diabetic, means which belongs to class 0, they are 99%, and the person who are diabetic, means those who belongs to class 1, is simply 1%. So this is the problem. What is that problem called as? You can say that this is a problem of unbalanced data. So the data set which is provided to you is unbalanced. Okay, so unbalanced data is given to you, where yes, you want to do a binary classification task, everything is fine, data set is also given to you, but 99% of your data is belonging to class 0 and only 1% of your data will belonging to class 1. Okay, or in other sense, if you are not taking this much huge imbalanced, this is also imbalanced, where 90% of your data belonging to class 0 and only 10% of your data belonging to class 1. In simple words, what I want to say is that for example, if you are having 1,000 records and you want to apply any of the supervised machine learning algorithm to classify the data into 0 and 1 category, the problem that you are facing is that 900 records are there which belongs to class 0, okay, and only 100 records are there which belongs to class 1. 100 records are there which belongs to class 1. That is the major issue, and this is what we are saying is a unbalanced data. Okay, so now this is an interview question,
And in this series, I will only talk about interview-based questions only. So now the interviewer is wanting from you that what are the techniques that you can imply here to solve this problem. This is a very major issue. Okay. First of all, you need to think here that if suppose this kind of dataset is given to you, can you use this dataset exactly to any of the binary classification models? Maybe you are applying a logistic regression, or maybe you are applying a decision tree, or maybe you are applying a random forest, anything. I don't care about that. But can we use directly this kind of combination? No. Why? Because if we are using this kind of data, what will happen is that my model will be more biased towards the 0 outcome as comparable to the 1. This is true. This is so true. It means that why? Because model is learning more records from the class which belongs to 0 as comparable to the class which belongs to 1. So our target should be to give the model equal amount of data. Means equal set of records should belong to 0 and equal set of records should belong to class 1. Right? Okay. So what are the different kinds of techniques and the approaches with the help of which we will be able to overcome that biasness kind of problem which might happen in this particular kind of a distribution of a data set? So the very first thing that we can do here is that, or what we can observe here is that we cannot choose accuracy as a parameter, as a evaluation metric. Suppose you are using this kind of a distribution. So the very first important thing is that in that case, when you are doing a model evaluation, whenever you are doing a model evaluation, so if you know there are so many techniques with the help of which we can evaluate our model in a classification task. For example, we can do via accuracy, we can do via recall, we can do via precision, we can do via F1 score, right? So what I'm saying is that whenever this kind of data set is given to us, the very first important thing to note here is that we never use accuracy as a model evaluation metric. Accuracy cannot be used. What's the reason behind that? What you can think of the reason why I am saying that accuracy can never be used? Because suppose if you are using the accuracy, what is the formula of the accuracy? The formula says it is nothing but true positive plus true negative divided by the summation of true positive plus true negative plus false positive plus false negative, right? Now here if you will try to observe, whenever I am saying that this is the formula where it simply depends on how many true positives are there and how many true negatives are there. Even though your true positives, where my model is not actually learning that which class it should classify as 1, at that point of time, even though my true positives will be low, but if my model will be able to generate all of them as true negative, so true negative portion will be very high, then also if you will observe, even though the true positive is low, but the true negative is very high, so what will happen is that suppose my model is saying that I am passing all the 1000 records to predict the model, and my model is saying that all the records are belonging to class 0. Means my model is not able to learn that which particular record will belong to class 1. Then also 900 are true negative, right? 900 records are true negative because actually 900 records belongs to class 0 only. Only the 100 records belongs to true positive, and now because they are also part of a I would say negative records, so they can be said as a false negative. So I will be having only 100 records which belongs to false negative. Then automatically my accuracy will be approximately equals to 90%, right? But if you will see, actually this is not the scenario. Actually my model is not at all learning that which records belongs to class 1. That's why at that moment accuracy is never a very good metric. You can go for maybe the precision, you can go for maybe the recall, or you can go for maybe the F1 score, but you should avoid this accuracy as the evaluation metric at that point of time. Now, second important thing, after understanding this part, second important thing what we can do whenever we are having this kind of scenarios is that what we can do is that we can try to use that technique called as oversampling, in which what will happen is that whichever records are of minority records, means the records which belongs to class 1, what we can do is that we can take the samples out of it and try to make these records towards the ratio of 900 only. Oversampling. So here what we are trying to do is that we are trying to make the ratio as same by increasing the number of samples belonging to the minority class. And here if you will see, this is the minority class, the class which is having a lesser number of samples. And this is something which is the majority class that we have, right? So here if you will try to observe, the second important thing that we can do here is that we can try to increase the number of samples or the number of records belonging to minority class from 100 to 900. In that sense also, I will be able to maintain the ratio of 50:50 for the class 0 and the class 1. And in this way also, we will be able to maybe, what I can do is that we will be able to maybe decrease that biasness thing inside the model, and our model will be able to generate a good result. Third technique that you can use to avoid this kind of thing is called as undersampling. Undersampling. What we can do in this technique? In this technique, our focus is not on the minority class. Our focus is on the majority class. So when I'm saying oversampling, there we are trying to increase the samples of the minority class. Minority class samples we are trying to increase. When I'm saying undersampling, in undersampling we are trying to decrease the number of samples in the majority class. So what I am trying to do here is that okay, I know that in majority 900 records are there which belongs to class 0. So what I will do is that I will try to maybe decrease the number of records to which is equal to the 100 records, right? So that in my data set, in total the number of records will be 200, that's it. But here also if you will see, the ratio will be maintained. I will be having an equal amount of records belonging to class 0. The same records will be there in the class 1. And in this way, again, I will be able to avoid that problem of biasness towards one class inside the model, right? This is another way with the help of which I can avoid the imbalanced kind of problem, right? Another way where you can try, what you can try is that you can use something called as SMART technique. This technique is basically responsible to generate the synthetic data. Synthetic data. In this way, what you can do is that you will be able to generate the synthetic data which belongs to class 1. Again, in this sense, you will be able to get a more number of records which may be synthetic or artificial, but still you will be able to maintain the ratio of that minority versus majority. Now you will be having the equal number of records belonging to class 0 and the class 1. And last technique which you can try is that what you can do is that you can try to maybe alter the cost function. You can try to maybe alter the cost function in such a way, alter the cost function in such a way that whenever, suppose you are using this original data that you have, so whenever your model is doing a false prediction, whenever your model is doing a false prediction on the maybe that minority class, on that minority class, at that point of time, what you can do is that you can try to penalize more. You can try to penalize more so that model will be able to get an idea while learning that this particular class is something where I need to pay more attention, where I can't be wrong, because already there are a few number of records for learning. So I have to keep a very good track of that. So these are the few techniques with the help of which you will be able to avoid that technique of uh, imbalanced data. And this kind of thing is happening a lot in real life scenarios. In real time scenarios, whenever you're dealing with any of the project where you're solving a classification kind of problem, this problem can happen. So how you can deal with that problem, and if suppose you are facing these kind of questions in an interview also, what techniques you can tell to them is what I'm just telling you here with the proper explanation of the same. So now we are discussing the second question which can be asked in an interview. Do you know what do we mean by K-means clustering algorithm? So I hope that everyone knows that whenever we want to make a clusters or we want to group the data, at that point of time, this K-means clustering is very much famous technique, right? In unsupervised machine learning algorithm. There is something which we called as K, which is an hyperparameter, right? So what the interviewer is asking from you is that whenever we are talking about the K-means clustering algorithm, how will you choose that value of K? So in a K-means clustering algorithm, so this is the second question that we are discussing. In a K-means clustering algorithm, how you can choose the value of the K? How to choose this value of K? This is the question that you need to answer, right? So this is a very vastly asked interview based question. Please focus on this session, that how basically you can answer this question. Now, whenever we are solving this problem of K-means clustering, there is something which is very famous method which is basically responsible to choose the value of K, and the method name is something which is called as elbow method. I'm not sure that how many of you guys have listened this method before, but this is the optimized, I would say, way, basically useful to check the optimal value of K, or I would say this method is helpful to choose the optimal value of K. How is that helpful for us? So majorly what usually happens is that whenever we are talking about this K-means clustering, the very first thing that is we randomly choose the number of centroids, right? We randomly choose the number of centroids here. So here the number of centroids that I am saying is nothing but is telling us the number of clusters, and the number of clusters is nothing but is the value of K. So here we are randomly choosing that number of centroids, and number of centroids is nothing but is equals to the number of clusters, and the number of clusters is nothing but is the value of K. Now when I'm saying the value of K is equals to 3, or when I'm saying that the value of K is equals to 4 or 5, how I'm choosing that? Randomly we are choosing, that's fine, but what should be that optimal value which is basically for my given dataset is helpful to give me the accurate number of clusters? How I can decide that? With the help of elbow method. So what this elbow method says, try to understand this. Elbow method is something which I would say is a graph of WCSS versus the value of K that you are getting. WCSS, the full form is within cluster summation of square. So the full form of WCSS is within cluster summation of square. Summation of square. What does that mean? The simple meaning is that assume that initially we are saying that the number of clusters is equals to 1. The value of K is equals to 1. What does that mean? That I am having only single centroid at that point of time. It means that in a bigger circle, I am having only single centroid, which is C, and all other are the data points that I have. For example, here I am having the data point P1, here I am having P2, here I am having P3, here I am having P4, and here I am having P5. When we are saying summation of square, cluster within cluster summation of square, means we are trying to find out the distance between that cluster with the corresponding points that we have within a cluster. Means you are finding out that with the help of a measure called as Euclidean distance. Euclidean distance. So how we are trying to finding out that value? We are saying that it is nothing but is equals to square root of C minus P1 whole square plus C minus P2 whole square plus C minus P3 whole square until so on C minus, if I am having 5 data points, P5 whole square. This is the way to calculate the distance, and this is something which I am saying is the summation of squares here within that cluster. When the value of k, and this is something which I am saying is also a WCSS. Now try to understand this point. When the value of k is equals to 1, at that point of time, obviously the value of WCSS which I am calculating will be very high. Now consider that when the value of k is equals to 2, means I am dealing with the two clusters. Suppose this is the centroid C1, this is the centroid C2, and here again I am having some specific points here. Here also I am having some specific points. For example, let's take only 5 points only. So here we are having P1, P2 and P3. Here we are having P4 and P5. Now how this WCSS will be calculated? We will do the calculation separately for this summation of squares SS1, which is nothing but is the square root of C1 minus P1 square plus C1 minus P2 square plus C1 minus P3 square. Similarly, here also we are trying to calculate what is the value of SS2, and the value of SS2 will be equals to simply C2 minus P4 square plus C2 minus P5 square, right? Now I have the value of SS1 and SS2. What is WCSS? It is nothing but is the summation of these things, SS1 plus SS2. Now here if you will see, as you are trying to keep on increasing the number of clusters, means the value of k, the value of WCSS automatically will keep on decreasing. What will happen when the value of k is equals to n? Means whatsoever be the number of data points that we have, that means number of clusters we are trying to create. Obviously at that point of time, the value of WCSS will be very low, approximately equals to 0 only. Means what we are trying to do here, or what elbow method says to us. It simply says that when you plot a graph between the number of clusters, which is k, and the value of WCSS, what is happening is that you will observe when the value of k is very low, WCSS value will be very high. Now as you move on decreasing the value of k, WCSS value will keep on decreasing, and then there comes a point, after that you will not see a much major change. Maybe this is the point where there is an elbow kind of structure which is happening, and whatsoever be the value corresponding to this point, maybe suppose here the value is 3, and that will be the final value of the optimal number of clusters that we are saying for our data set. It may vary. For maybe your data, you are getting the value as 3. When you change your data set, it might be 5, it might be 7, it might be 1, it might be 2, and so on. I don't care. But what we are trying to do here is that in elbow method, we are trying to create a graph between the value of the k and the value of the WCSS. The graph at the point where this elbow kind of structure is happening, this is what we are looking for in our graph. This elbow kind of structure is happening, that we would be suggesting as the optimal value of k. That is something which we are saying is the optimal value of k that we have. And that's where the concept of this elbow method is coming into picture. So if suppose in an interview someone is asking to you that how basically you can choose the optimal value of k, your first answer should be that we can do this specifically in in K-means clustering algorithm with the help of this elbow method. What is this elbow method? I completely talked about that basically we are calculating the value of WCSS. How we are doing the calculation? I have just showed you. And then we are trying to create a graph between the value of K and the value of WCSS. And what we are observing is that as we keep on increasing the number of clusters, the value of WCSS will keep on decreasing. That's the important thing. The point where the value of WCSS is minimum, and after that point, even though we are decreasing the number of clusters, there is not that much sharp decrease in the value of WCSS, is what we call as an elbow point, and that's where we will fix the value of K, right? This is the second important vastly asked interview based question. Now the third question, which is also related to this K-means clustering algorithm, is that they can ask you that, do you know what is the difference between K-means versus K-means plus plus? So the first question that we have discussed, so let me mark it right like that so that we will be able to get an idea. This is the first question that we have discussed about the imbalanced data. Second question that we have discussed about the choosing value of K. The third question that now I am discussing is that do you know that what is the difference between K-means and K-means plus plus? So usually many people don't know this fact that there is something called as K-means plus plus as well. So when I'm saying K-means clustering algorithm, it's a standard algorithm that we used to study, where we used to say that we are randomly initializing the number of centroids. After that, we are trying to calculate the distance between the centroids to the remaining data points that we have, and this process we will keep on repeating until there is some fixed structure of centroid we will be able to get, right? Now, in K-means plus plus, what usually happens is that, so when we are talking about this normal K-means, and when you are trying to randomly initialize that centroid value, it might happen that, for example, you are having these data points. Okay, suppose you are having these data points. Now, randomly you are trying to initialize the centroids, and the centroids initialization will happen like here and here. But what I want is that in order to make a proper cluster, my need is that one centroid initialization should be at this part and another centroid initialization will be at the another part, so that I will be able to form two well-defined separate clusters. But now what happened is that I will be able to get these two clusters which are very close to each other. So K-means plus plus will take care of this fact. In K-means, at that point of time, researchers haven't basically observed that this might be the problem, that when we randomly initialize the centroids, at that point of time, they can be very much closer to each other. And if they're very much closer to each other, then obviously they will form clusters which are not at all helpful for us, which are not at all useful for us to make the groupings of the clusters that we have. Because in this way, we will be able to completely get rid of various data points which are very helpful for us, right? So it is very much important to have the initialization of centroids, and they should be too far from each other so that we will not be able to get a coinciding clusters, and we will be able to generate a very good amount of results, right? So at that point of time, this concept of K-means plus plus came into picture. This K-means plus plus will say that I will take care of the centroids initialization, centroids random initialization mainly. I will take care of the centroid random initialization. Okay, initialization, initial values in such a way that they will be not too close to each other. They will be not too close to each other, right? That is the important advancement that was done by the researchers. what is the mathematical intuition behind that, what mathematics they have used in order to separate those two clusters so that they will be not too close to each other. That you can refer to the research paper, original research paper. Go to Google Scholar website, with the help of which you will be able to see that. I'm not going in that much depth towards the mathematical side, but what I want to show you here is that this is the major difference between K-means and K-means plus plus. So if someone is asking to you in future in any of the interview, what is the major difference between these two, that is the only difference. Apart from that, whatever algorithm we have studied in our K-means is exactly the same valued for the K-means plus plus. Even if you will observe, whenever you're calling this K-means clustering algorithm, by default, internally now in today's scenario, whenever we are calling this K-means clustering algorithm, by default there is an initialization of K-means plus plus only. But usually, because these are the default parameters, we didn't pay much attention. You should pay, and if you will observe and go to the documentation after seeing this session, you will observe that they have mentioned that K-means plus plus. So this is the third question which I want to discuss in the interview part. Now let's talk about the another fourth question. And the fourth question says that what is the motivation behind using a random forest algorithm? I hope that everyone is aware about the fact that in maximum scenarios, random forest gives us a good result as comparable to other algorithms, whether we are dealing with a classification task or we are dealing with a regression task. So the most important thing is that what's the motivation behind using that? Why we should go for this kind of algorithm? So the question says, let me write the question first and then we will talk about the approach of that. So this is the question number 4th, right? And this says the motivation behind using a random forest algorithm. Motivation of using random forest algorithm. So mainly whenever we are talking about the motivation part, here if you will observe, random forest is something which is an ensemble technique, right? It is something which is an ensemble technique. By saying that it is an ensemble technique, we all know that in this particular technique, multiple decision trees are working. Or I would say multiple decision trees are playing a very important role, right? Whenever we are talking about an ensemble technique. Now, if you will see or if you will observe, when we are dealing with a single decision tree, they are prone to overfitting, right? So whenever we are dealing with a simple decision tree, we all know, and you can easily observe also, that while you will do the implementation of a single decision tree, in maximum instances you will observe that they are prone to overfitting. Now, what we are trying to do here, or what is the motivation for using not decision tree but multiple decision trees cumulative? Because by using that random forest, which is an ensemble technique, we will be, first of all, a very good thing is that we will be able to avoid the problem of overfitting. We will be able to avoid the problem of overfitting. Why? Because now we are taking a mixture or a subset of records that we have, and those, for every particular subset that we are using here, for example, you are passing that I want to use maybe 10 decision trees. So 10 decision trees are working simultaneously to generate a one outcome. So either we are taking maybe the majority voting, right? Whenever we are doing a classification task, so we are taking the concept of majority voting, or suppose we are doing a regression task where we are taking the concept of taking the average, we will be able to avoid that problem of overfitting. which is the major motivation. So again, random forest is basically helpful whenever you are dealing with any of the classification task, right? Or any of the regression task. It is helpful for both. But what's the major implication is that the problem which we were facing at the time of using the decision tree, now we will be able to avoid that because of the because of the usage of that multiple decision trees. That's why it's called ensemble technique. And that's the major motivation that you can say of using a random forest algorithm, right? The next important question which can be asked from you in an interview, that is the question number 5, is that how can you make your model more robust to outliers? So what are the outliers first? So the question says that how can you make your model more robust to the outliers? So now the very first question which should be coming in your head is that what is the meaning of outliers? First of all, what do we mean by outliers? So outliers is something which you can say is the kind of a data which is absurd as comparable to the other records which are given to you. Let me give you one simple example. For example, you are doing a survey of the people, or of the young people I would say, who are in age of 25 to 30. You want to do a survey of their salaries. That in India, okay, in India, what is the average package or average salary of the person who belongs to the range of 25 to 30? You did one survey and you find out that, okay, there is someone having the age 25 is earning per month 1 lakh rupees. Then there is someone who is having a age 26 and is earning maybe 1.3 lakh rupees. Fine. Then there is someone who is in the range of 27 and is earning maybe 70k rupees per month. Then there is someone who is having a age of 25 and is earning maybe 50k. There is someone who is in the age of 30 and is earning maybe 1.7 lakh. Something like that. You are doing a survey. Now you find someone who is in the age of 29 and is earning 1 crore, 1 CR. Now if you will see, with this particular data record which I have, if I want to take a survey and if I am doing a mean of all these things, right? Only with this single record, my mean value will be changing drastically. And I will not be able to get the actual average income or actual average salary of a person belonging to a range of 25 to 30. So I can say that this is someone which is having a different side of capability as comparable to the records which I have until now. And I can say that this is something which is an outlier. So this kind of outliers can give or have the potential to give a wrong result, right? So what we want in our model, we want that these outliers either should not be there, or if they are there, if they are already been there in the data set, so my results will not affect much via having these outliers. So how can you make your model more robust in that case? If this is the question asked from you, what should be your answer? So the very first thing that you can do is that whenever you are having such kind of scenarios where there are outliers present in your data and you know that these outliers are there, first of all, the question can be, how can you detect that? So these questions can be divided into two parts. The very first thing that they can ask from you, that first of all, how can you detect that these are the kind of outliers that you have? One of the most famous technique is something which we called as a box plot in statistics. So in box plot, what you can do is that you will try to find out what is the value of Q1, which is nothing but you can say is a 25 percentile range. Okay. After that, you can easily evaluate what is the value of Q2, which is something which you can say is 50 percentile. After that, you can calculate what is the value of Q3, which is nothing but 75 percentile in a given data that you have. After that, what you can calculate is the value of lower whisker and upper whisker using these values, lower and upper whisker. So what I can do is that I can divide this same question into two parts. So question number 5 is, let me change this question now. Question number 5 is saying that how can you detection of outliers? Obviously, first of all, you need to detect that, and then you can see that how you can deal that, right? Detection of outliers. So this can be also a separate question which can ask from you in an interview, that how you can detect the outliers. So for that, one of the important technique that you should know is the box plot. What is lower whisker and upper whisker? Lower whisker says that it is nothing but what is the value of Q1 minus 1.5 times the value of IQR. IQR is something which is the interquartile range, which is something you can say is the value of Q3 minus the value of Q1. What is the value present at 75 percentile minus the value present at 25 percentile. When I am saying upper whisker says it is nothing but is equals to Q3 plus 1.5 times of IQR. Again, this is something which is the difference between the values of Q3 minus the value of Q1. So once you will be able to calculate all these 5 values, now the value which lies below the lower whisker and which lies above the upper whisker is something which you can say is an outlier. Similarly, same values you can calculate for the violent plot as well. So these are the kind of plots which you can generate and which is helpful for you in order to majorly detect the outliers. Detect the outliers. So this is the detection part. So with the help of this, you will be able to get an idea that the values which are less than the lower whisker and the values which are greater than the upper whisker are the values which you can state forming a outliers, right? That is fine. That is completely fine. But now I will be able to detect that. Now the question, again, the 6th question I can say, which is there, is that, okay, you will be able to detect that using maybe the box plot or maybe the violent plot. The question is that how you can now make your model robust to outliers. How can you make your model robust to the outliers that you will be able to detect? So what you can do? Now, in order to make the model more robust to outliers, the very first thing that you can do is that you can maybe add the regularization in your model. Suppose if you are dealing with a regression kind of a problem, so what you can do is that this regularization, what it will try to do, it will try to reduce the variance. It will try to reduce the variance, right? So how you can do that? You can maybe add L1 and L2 regularization that we usually have in our regression problems. You can just understand that concept if you are already aware. I hope you will be able to get my point. Apart from that, what you can do is that you can maybe change the evaluation metric. How? Usually the MAE, mean absolute error, is more robust towards outliers as comparable to mean squared error. So you can change the evaluation matrix to MAE, which is nothing but mean absolute error, right? Mean absolute error. Usually we use MSE, mean squared error, but you can change that and use MAE because this is more robust towards the outliers. After that, apart from this, what you can do is that in order to make your model more robust to outliers, you can use or you can try different kind of models by using ensemble techniques. So in this kind of scenarios, ensemble models can work or can perform better as comparable to one single model. For example, decision tree might not work better, and random forest will work better in these scenarios, because we are having a lot of outliers, and these ensemble kind of models can work better in that particular scenario, right? Apart from that, the very last thing which you can do is that, because you know there are outliers, you can completely try to remove those outliers by the knowledge of IQR and by the knowledge of the standard thumb of rule, which says that 99.7% of your data lies within 3 standard deviation that we have. So, but this, the last point which I am saying, removal of outliers may cause a low loss of the important information as well. So it comes with the one disadvantage, that somehow, if suppose those outliers are giving me some sort of information, I am losing that. So once make sure that these outliers are something which are not at all useful for your model's performance, then only take a chance to remove those outliers. Otherwise, you can go with above techniques in order to deal with the outlier and in order to make your model more robust to those outliers, right? So these are the specific techniques which you can use, or which you can tell to the interviewer if you are facing this kind of interview based question where they are saying that, can you tell us some tricks or techniques where you can make your model more robust to outliers, right? So these are the things that you can tell. Okay, so I think we are good to go towards the 7th question. So the 7th question says that, out of MAE and MSE, what do you think is a metric which is more robust to outliers? I hope I'm making sense to everyone. So what is the question says, or what is the problem statement? That suppose you have been provided a 2 evaluation metrics for a regression kind of a problem. One is something which we called as MAE, and another one is something which we called as MSE. I hope everyone knows what is the meaning of these terms. When we say MAE, it is nothing but, you can say, is the mean absolute error. Mean absolute error. And when we say MSE, it is something which I can say is the mean squared error. Mean squared error. Now, the formula to calculate this mean absolute error is that suppose you will be having n data points, so it will be summation of I equals to 1 to n, the absolute value of the actual data of yi minus the predicted data, which is y cap. This is something which I am saying is a mean absolute error. When I am talking about mean squared error, this is something where you can say that it is a summation of I equals to 1 to n, where what you are trying to do is that you are trying to do a squaring of that. For example, y of I minus y cap of I whole square. And to normalize that values, you can say 1 by n to calculate that mean, 1 by n. There is something which is other term also called as root mean squared error, which is something which we called as RMSE, where what we try to do is that we try to take the square root of that term, if you know that thing. So here basically whatever be the value of MSE we have, which is the summation of I equals to 1 to n, y of I minus the predicted value of y cap, okay, predicted value of yi cap square. So here we are doing a square root of that term. This is something which we are saying is a RMSE. Now try to understand, when I am saying MAE and when I am saying MSE, what do you think? The question says in an interview that what do you think is the evaluation metric which is more robust to outliers? So we already know in our previous questions that what is the meaning of an outlier, right? So when I'm saying MAE and MSE, what do you think? So the correct answer is that MAE is something which I can say is more robust to the outliers. Why is that so? Why is that so? Why I am saying like this? Because if you will observe here, by just seeing the formula itself of MAE and MSE, what you are doing is that you are trying to square the error terms, right? In case of MSE, you are trying to square them. So means you are in a way increasing that error term value. So if there is an outlier, the error term will be very high, and after that you're doing a square of that. So how it can be more robust to outliers? So the correct answer should be MAE, right? The next question which can be asked from you as a question number 8, which I want to discuss here, is that okay, suppose a data set is given to you, okay? In that particular data, we usually have the missing values, right? So suppose that a data is given to you, and inside that data set, you have seen that there are a lot of missing values for a set of records or the columns or the features that you have. Now the question is that how can you handle these missing values? What is the way to handle the missing values that you have encountered? So what should be the answer of this, or how you can handle those missing values? So the very first approach that you can do is that you can do a data imputation. Now, data imputation of those missing values, what are the ways to do that? There are multiple ways. Either you can do the data imputation using the mean, or with the median, or with the mode. Now, the next question, when you suggest that this approach to the interviewer, he will definitely ask you that what are the key things that you will take in your head while doing the imputation with mean, median, or mode, right? So now here, if you will observe, if you are having an outlier, at that point of time, what do you think out of these three will impact the mode? So for sure, when I am talking about mean will impact more whenever we are having an outlier. I took an example of the salary people, right? This example. There, if I will tell you what is the mean, so you will say to me that the mean will be the summation of all these values that I have, which is 1 lakh plus 1.3 lakh plus 70k plus 50k plus 1.7 lakh plus 1 crore, divided by the number of terms that we have, which is equals to 6. But when I will talk about the median, because first of all you need to make it in a sorted fashion, so you will say it will be, in after sorting, it will be 50k followed by 70k followed by 1 lakh followed by 1.3 lakh followed by 1.7 lakh followed by 1 crore, right? Now in this case, the median will be the summation of these two terms divided by 2. If you will observe, the mean value is very high due to this outlier as comparable to median value. What I want to say by this statement is that mean usually impacts more with the outliers. Right? So what you can do is that while doing the data imputation, you can check the distribution of the features that you have in your data set. Distribution of each feature. Now, when you check the distribution of each and every feature, if you will observe that there are outliers in your data, means your data is not symmetric data, like kind of this is called as symmetric data, right? If suppose this kind of distribution is there, if your data is symmetric one, at that point of time though, you can do the imputation with a mean. So if you are having a symmetric kind of a data distribution, because it indicates that okay, you are not having that much outliers here. Almost to symmetric, if your data set is there, if your distribution feature is there, you can do the imputation with a mean. If suppose you are getting a non-symmetric kind of a data, where you are observing the pattern that you are either getting something which is a right skewed kind of a data like this, or you're getting something which is a left skewed kind of a data like this, at that point of time, it is non-symmetric, which indicates that there can be the outliers which are present inside your data set. So at that point of time, you can do the imputation with the median, right? Because we know that outliers impact lesser in median as comparable to the mean. Whenever we are having a categorical kind of a data, right? Whenever we are having a categorical kind of a data, at that point of time, you can do the imputation easily with the help of a mode. What is mode? It is something which is having a higher frequency. That is what we will be easily able to calculate at any point of time. Okay, so this is one of the way with the help of which we can handle the missing values. Apart from that, there is something called as KNN predictions. So with the help of which, so KNN is also used as a data imputer. So what we can do here is that we can use this KNN model to make the predictions, and we can use this KNN model as a data imputation or as a data imputer. We can pass the values as the features that we have in the KNN model, and model will be able to predict to me that what should be the feasible value that we can pass inside the missing values. So these are the ways with the help of which we can deal with any of the missing value present inside my data set, right? Coming to the next question which can be asked from you, the question number 9th, okay, which says that, okay, we know that whenever a distribution is non-symmetric, we have two different kinds of distribution. Whenever the distribution is non-symmetric, we have two different kinds of distribution. One is called as left symmetric, another one is called as right symmetric, right? So here one is called as the left symmetric distribution, and another one is called as the right symmetric distribution. When we say left symmetric distribution, what do you think is the relationship between the mean, median, and the mode? So this is the problem statement. So what you need to understand here is that you need to tell to the interviewer that, okay, the distribution is non-symmetric. He or she is simply saying to you, now that might be left symmetric or that might be right symmetric. Can you tell us that what is the relationship between the mean, median, and the mode for both of the relationships that we have, which is left symmetric and the right symmetric? So what is left symmetric distribution? Where we are having a left side more symmetric, more alignment, and then there is a distribution like this. When I am saying right symmetric, then right side there is a more skewness. Or I should not mention symmetric, it would be better that I would mention skewed, because it's a kind of a skewed distribution that we are talking about. So right skewed, and another one we are having as a left skewed, right? Left skewed. Now, just try to observe here. In case of a right skewed, what is the mode? Mode is the highest frequency. So I can say that this is something which is the mode that I have, right? This is something which can be the median, middle value that I have. And this is something where there is an average called as mean that I have. So as you know that whenever I am moving towards the right side, the values keep on increasing, right? So I can say that mode is having a lesser value as comparable to the median, which is further having a lesser value as comparable to the mean. So this is a kind of a distribution that I have when I'm talking about a right skewed distribution. So if someone is asking to you, what is the relationship between mean, median, and mode? Whenever a distribution is of right skewed, your answer should be that mean value should be very high as comparable to median. Further, median will be very high as comparable to the mode. Next important question. For the left skewed, what will be the relationship? So now you can see this is the mode, right? This is the mode in this case, which is having a highest frequency. Now we know that this is somewhere we will be having the median, and this is somewhere where we will be having the average as the mean. So what is the relationship which we are getting? Just the reverse one. The values will keep on increasing when we are moving from left to right. So now if you will observe, the mode is having a very high value. Median is the middle one, right here as well, and mean is having a very low value. So when I am talking about a left skewed, relationship will get changed. So for the left skewed, mean is lesser than the median, is lesser than the mode. When we are talking about right skewed, mode is lesser than the median, is lesser than the mean. And I have showed you diagrammatically as well why is that so. So I hope that this is also making sense to everyone. Coming to now the next question, which is question number 10. And the 10th question says that what is the important difference, or what is the major difference that you can see in terms of L1 and L2 regularization? So we know that whenever we are dealing with a linear regression problem, there is something called as the problem of overfitting, right? And in order to cure that problem, we came to the concept of regularization. Now the question says that whenever we are using a regularization in a regression problem, right? So there is something called as L1 regularization, and then there is something which we call as L2 regularization. What is the major difference between these two? So when we talk about this L1 regularization, which is also known as lasso regularization, right? Which is also known as lasso regularization. And when we talk about L2, it is also known as ridge regularization. There is a very minute difference between these two. First of all, everyone should know that this kind of regularization is mainly helpful to avoid the problem of overfitting, right? To avoid the problem of overfitting, we are moving towards this particular regularization concept. Now, whenever I'm talking about this lasso regularization or L1 regularization, what happened to the loss function? So basically, when we are dealing with a simple linear regression problem, what happened? That we do have a loss function. Suppose I am representing that loss function as L. What I am saying is that this loss function will be something which is a squared loss, mean squared loss, right? Mean squared error, which is nothing but is equals to 1 by 2m, where m is the number of data points that we have. Summation of I equals to 1 to m. What is the value of the actual minus what is the value of the predicted whole square, right? Here you can mention I. So this is something which we understood as a loss function of a linear regression problem. So whenever we are applying any linear regression model, so our agenda is mainly to, focus on this loss function so that the error rate will be minimum. Now when we move towards the lasso regression, basically it says that I will try to penalize the coefficient, which is the slope. What is the value of y cap here? Y cap is something which is equals to mx plus c, right? So basically L1 regularization comes under the law changing of the loss function, which takes L as it is, plus there is some parameter called as lambda, which is the coefficient, which is the rate by which you want to penalize the value, absolute value of this m of I, right? Where I will again vary from, I would say, let me write it like this: lambda times summation value of I is equals to 1 to m, absolute value of m of I. This is something which is, you can say, is the loss function of the lasso regression, right? This is the only difference. So basically what we are trying to do here is that the overfitting problem will not happen. We are trying to add one more parameter on top of the original loss function that we have in our linear regression. When we talked about L2 or the ridge regression, it says that the loss function will be equals to the original loss function L that I have already defined in the below part. This is the original loss function that we have, plus what we are doing here is that lambda times summation of I equals to 1 to m or 1 to n, where n is the number of data points that we have, mi square. So here we are taking the squaring of that. Now, this is the another loss function that we will be able to get that whenever we are talking about a L2 regularization. Okay, so majorly if you will observe here, in both of these cases, what we are trying to do is that we are trying to penalize the coefficients, the slope value. Why is that so? Because here if you will observe now, for example, you are dealing with any linear regression model, and you will be able to get this kind of a straight fit line on which all the data points are there. So here if you will observe, when you are applying a linear regression model with a very normal loss function, you will be able to get the error as 0, right? But now when you applied that regularization, whether it be L1 or L2, what will happen? The same error, the same loss function will now is not equal to 0 and is having some constant value. Now your purpose is to decrease that constant value, and by doing that you will not be ever getting that kind of a straight best fit line. You will either be getting somewhere here or maybe somewhere here, these kind of lines where the error is not exactly equal to 0. Here if you will observe, usually what happened is that at each and every time we are decreasing this value of m1, m2, m3, m4 and so on. So at one point of time in lasso regression, what happened is that the slope value will become 0 for those features which are not pretty much important for the model. So in a way, what I want to state here with this question, that this particular lasso regression is also having another application of feature selection. So it will be able to help us to select the features, because at each and every time what is happening is that when you are applying this lasso regression, the value of the slopes will keep on decreasing at every iteration. You will observe that for those features which are not that much important for us, the value will automatically will become 0 after some iteration. And at that point of time, you will realize that for those features where the value will become 0, these features are not that much important for our model. So in a way, lasso regression is also helpful to select the important features, right? Okay, this is the important thing which I want to talk about as a question number 10, I believe. Now the next question says to us that, can you discuss a scenario? Can you discuss a scenario where the recall measure is very, very important? Recall measure is very important as comparable to the precision. Recall is important as comparable to the precision. So can you talk about any scenario here? Okay, first of all, we need to understand here what is the meaning of a recall. So I hope that everyone is aware about the confusion matrix here, right? Everyone is aware about the confusion matrix here. What is the confusion matrix? Here suppose if I am having the actual values, and here suppose I am having the predicted values. Suppose I am dealing with a binary classification problem where I am having a 0 and the 1 classes, and in the predicted also 0 and 1 is there. This is something where I am saying it is true negative, right? This is something which I am saying is the false negative. This is something which I am saying is the false positive. And this is something which I am saying is the true positive, right? Whenever I am saying recall, it is nothing but is a measure of how many true positives are there out of actual positives. What are the actual positives that I have? These are the actual positives which I have here, right? So here if you will see, it is the ratio of TP, true positive, divided by true positive plus false negative, right? Fine. Now this is the meaning of a recall that we have. Okay. So here if you will observe, when I am saying that recall measure is highly important as comparable to precision, what I mean to say is that in a way I want false negative in my case to be very, very low. Because as you can observe in the formula, that for those values where the false negative will be very low, only when you can make the recoil as a very high very high value. Now let's try to consider a scenario where this can be a situation. Just recently we all came across with the COVID diseases, right? COVID viral infection. In that case, what is the meaning of a false negative, by the way? It means that actually you will be having the value as 1, but prediction says the outcome as 0. Now consider a scenario where actually the patient is COVID positive, but after using that kit, by doing a self analysis that whether it is COVID positive or not, or maybe by using a RT-PCR test, the patient came across a result which is saying that he is not having a COVID. What a blunder situation this is, right? With the help of this situation, automatically his family members or whomsoever he will encounter all are in a very difficult situation, right? Apart from that, you can consider an example of any healthcare domain. For example, you are dealing with a cancer data, okay, and the data set you need to predict as an outcome that whether a person is having a cancer or not, or whether a person is having those cells in it which are cancerous or not. So if suppose actually that person is having a cancer, but your prediction is saying that that person is not having a cancer, how dangerous situation is, right? So you can talk about these scenarios in an interview where you can say that at this point of time, I want my false negative to be very low. I can understand that what is false positive. False positive meaning is that actually the prediction is saying 1, but actually it is 0. Means a person is not having a cancer, but still prediction is saying that he is having a cancer. Or actually the patient is COVID negative, but prediction is saying that he is COVID positive. It's okay. He can take the precautions pretty well. But what is more dangerous out of these two situations, at least whenever we are dealing with a healthcare kind of a data where we want to do these kind of predictions, we always want false negative to be very, very low, because we can't play with the lives of the people to be very, very low. So in those situations, you can discuss the scenario where you are dealing with any healthcare data that, and you can say that at that point of time, I will specifically take care of this recall. I want this recall to be very, very high. At least some good number will be there in order to make sure that false negative will be low, in order to make sure that whatsoever model is conveying to me is perfectly fine for any kind of a healthcare data set that I am dealing with, right? Now, another interview question is just reverse of the above one, where they can ask you that can you discuss some scenario where precision can be the most effective one as comparable to other important evaluation metrics that we have. So what I'm saying is that instead of recall, precision is somewhere having a huge importance. Precision is very important. So again, here also they want you to discuss any kind of a scenario that you can have. So here now, if you will try to observe, what is the meaning of precision? Precision says how many true positives are there out of the predicted data. Out of the predicted positives, how many true positives are there? Means it is the ratio of true positive divided by true positive plus false positive. This is the meaning of, I would say, precision. Now here, if you will try to observe, just observe one thing. When I am saying that precision is a important metric, it means that what we want is that false positive to be very, very low. This is what we want. We want the value of the false positive to be very, very low. Perfectly fine. So now here, if you will try to understand, when the false positive will be very, very low, at that point of time, precisions will be high. Now, what is the meaning of false positive? The meaning of false positive is that Actually, data is 0, but prediction is saying the value as 1. This is the meaning of false positive. Actually, it is 0, but prediction is saying as 1. So, the simple thing here to understand, suppose I am talking about a scenario of a spam classification where a mail is coming up and my model is able to classify that whether a mail belongs to a spam class. If it is belonging to a spam class, I will label it as 1. If it is not a spam, then I will label it as maybe 0. Now, in this particular scenario, if you will observe, suppose actually the mail is not spam. Mail is not spam, means that is an important mail, but it is going towards a spam folder, and then maybe there is some deadline towards that mail, you need to do something important, you miss that. So under this kind of a scenario, you never ever want to take risk of false positive. You always want that false positive to be very, very low. At that point of time, you always look for a precision kind of a evaluation metric which will give us a good precision, which will give us a high precision. That is the overall scenario point that I can discuss, or you can also discuss in an interview if they can ask you these kind of questions, because in a data science interview they can also talk about the scenario based questions. Okay, so let's move ahead towards the next important interview based question, which is question number 13. So this question says that what is central limit theorem? Have you ever used that? And if yes, how it is helpful? So this is one of the very vastly asked question with respect to the stats portion. The meaning of central limit theorem. Central limit theorem. So this theorem states that given any random variable, okay, given any random variable for which you don't know what distribution it belongs to, if you take the random samples out of it various number of times, if you take random samples out of it and that too various number of times, usually it's experimentally proven that times would be more than or equal to 20. At that point of time, what usually happen is that if we take the average of that, that will become a normal distribution. Very, very important theorem. So there is a random variable x that I have, and if I take this sample out of this, maybe x1, then I'm taking x2, then I'm taking x3, and I will keep on repeatedly doing this task until xn number of times, and then I will try to do the average of all these things. Okay, so what is observed is that this particular distribution will be normal distribution, having, I would say, normal distribution having value x, which is having the mean as mu and standard deviation as sigma square divided by n. Okay, so this is a kind of a distribution which is forming up normal distribution. So initially when I was using that x random variable, I was not aware about the distribution of this x, but ultimately after doing several experiments a number of times, where it is experimentally proven that this n is somewhere less than greater than equals to 20, the distribution will become normal distribution. Normal distribution. So doesn't matter what distribution you are starting. For example, you are starting with Bernoulli distribution, but it will become, after several iterations of taking a sample, it will become, and taking the average of that, normal distribution. For example, how it is useful? For example, suppose let's take an example of a Ola company. I'm just taking some random example here just to demonstrate the importance of this theorem. Okay, so initially, so they designed something new features. So this company suppose designed some new features, And with the help of those new features, they want to keep a check that whether people will book more rides on Ola or not. Okay, that's the simple thing, that whether a person will book more ride after adding the new feature, or the ride consumption will be the same only after adding this new feature. So it's a kind of a Bernoulli distribution that we have, where either it will be yes or it will be no. At that point of time only this Bernoulli distribution will help. I hope everyone is aware about this fact. So now either there will be a consumption of more rides, or there will be no consumption of more rides. Now at this point of time, what will happen is that when those people will take a random samples out of it several number of times and will take an average of that, they will be able to get this normal distribution. They will be able to get a distribution somewhere like this, right? So this is a kind of a normal distribution. And now with the help of understanding the statistical properties about this distribution, they will be able to capture more properties of the same. They will be able to understand more kind of interrelationships between the same, and they will be able to conclude it better way. So this is the important thing that you need to understand. The very next question which can be asked from you is that what is the meaning of normal distribution, or what is the meaning of this Gaussian distribution? So what is this normal? And let me tell you, this is one of the same thing, or the Gaussian distribution. What is the meaning of that? So this is the function. The function here is something like this, where f of n is something which is equals to 1 upon sigma square root of 2 pi, and here it is exponential of minus 1 by 2 x minus mu by sigma whole square. X minus mu by sigma whole square. This is a kind of a, I would say, probability density function, which is also known as PDF, probability density function, which is also known as PDF of this normal distribution. What it states here, if you will see, mu is something which I would say is the mean value, or that is also, we can say mu is mean, and sigma is something which you can say is the standard deviation in this particular equation. Now here, if you will try to understand this equation, this is a function. If you will try to take the numbers, you will see that this kind of a function it will form something like a bell-shaped curve, something like this kind of a curve. I'm not able to draw it properly, but you can observe it's a kind of a symmetric distribution, something like that. Okay, so it's a kind of a bell-shaped curve which we will be able to get by a above function which I have written above. And here, if you will observe, this is the value which is something which you are saying as a mean, and in this distribution the value of mean is equal to the value of the median, is equal to the value of the mode. And in every practical real life scenario, whenever you will observe any kind of a data, you will observe in maximum data set, you will having this kind of a pattern where there is a symmetric kind of a distribution. For example, very simple example if I want to give you all is the score of the students. So you will observe that when a student got some score, suppose there are 100 students, and if you will try to plot the curve of those students, of the scores that they are getting, you will get this kind of a curve specifically. So this is something which we called as a normal or a Gaussian distribution. It's a bell-shaped curve, kind of a symmetric distribution, where the value of the mean, median and the mode are equal, and this is the function value which we have. Fine. The next important question which you will be able to get as a in an interview is that what is the meaning of a hypothesis testing? What is the meaning of a hypothesis testing? Okay, and its correlation with the p-value. very, very important and the crucial point to understand, and it can be useful for various of the projects. So what usually happen is that whenever we are talking about a hypothesis testing, what does that mean? Usually what happened is that you are taking a sample of the data. You are taking a sample of the data from a complete population that you have. Now, when you take the sample of the data from a complete population that you have, you will try to go with some assumptions and you will try to make some conclusions. So, you conclude something. Okay? After making the conclusions, you obviously say that whatsoever conclusions I have made for this sample is equally valid for the complete population. For the complete population. So, for this particular purpose, whatsoever assumptions you are taking is something which we called as hypothesis. And this testing is something which we completely known as hypothesis testing. Here, what will happen is that usually whatsoever assumptions we believe, for example, let me take one example here. For example, I am saying that the mean score of a student of having 100 students in a class, the mean score is, or the average score is, suppose 80. This is what I am saying. This is what I believe. Now, what I will do is that actually in a population, how much is the size? N is 100. But I took the sample out of this data. Okay, I took a sample out of this data, and I am saying that the number of samples which I am picking up is suppose 30. Okay, now what I will do is that I will try to conclude, or I will try to see that whether from this random set of samples which I picked up, which is equals to 30, is the value of S bar is approximately equals to 80 or not. So this H note, which is called as the null hypothesis, there are two things that we have inside here. One is called as null hypothesis. Null hypothesis is something which we believe. For example, here I believe that the value of mu is equals to 80. And then what other thing can happen is something which we called as alternate hypothesis while doing this testing. Okay, so this is called as alternate hypothesis, where I am saying that mu is not equal to 80. Now, either we will reject this null hypothesis, or our purpose is to accept this null hypothesis. So either there are two things that we can do. Either we will reject the null hypothesis. When we will reject? When we will be able to get a value of the mean which is not equal to 80, which is not approximately equals to 80, the sample mean I'm talking about. Or another thing is what we can do is that we will be fail to reject the null hypothesis. These are the two things that we can do here. We will be fail to reject the null hypothesis here. Okay, now these are the two things that can happen. So now you will perform the experiment on the sample data, which is S is equals to 30, and you will try to see that whether you are getting the value of this S bar approximately equals to 80 or not. If suppose you will be able to get that, in that case, obviously you will be fail to simply reject the null hypothesis. If suppose you will not able to get the value approximately equals to 80, in that case you will simply reject the null hypothesis. So our major focus while doing this task is to take account that null hypothesis which we are assuming. Is this fine or not, right? In any of the experiment. Then what is this p-value? P-value is the probability of the null hypothesis that we are taking, you can say. So if suppose the p-value is lesser than, there is something called as alpha, which is the significance value, that we are having. And by default, so this particular value is also experimentally find out, and by default it is something equals to 0.05. And if suppose your value p, which is the probability, is less than even this significance value, ability to take the risk, in that particular case you can simply reject the null hypothesis. You can take the decision to reject the null hypothesis. And if suppose the value of p is greater, so in otherwise case, what you can do is that you can say that I will be fail to reject that null hypothesis. That is the overall idea in terms of what is the meaning of hypothesis testing and p-value. So if someone is asking you this thing, this is the overall story that you have to explain to them, right? Coming towards the next question, which is the question number 16. What is the difference between population versus sample? This can also be asked, right? Very simple question. You can say that population is something which is a complete, I would say superset, complete superset. Inside that, what is sample? If you take the subset out of that, if you take the subset of that population, that is something which we simply known as a sample, So this is the complete set which we called as a population here, right? Very simple, very basic. Next question which can be asked from you is that, I think that is question number 17, which can be asked from you is, what is the meaning of type 1 error, very vastly asked question, versus what is the meaning of type 2 error? What is the basic difference between these two, type 1 and type 2 error? Now, as we have seen that we have the null hypothesis. Now, this null hypothesis is actually can be true, or in an actual scenario, this null hypothesis can be a false, right? Now, on the column side, on the row side, what I can say is that either you will reject, there are two things that can happen, right? Either you can reject that null hypothesis, or maybe you will be fail to reject the null hypothesis. These are the only two things that you can do. Either you reject that null hypothesis, or you fail to reject that null hypothesis. So if you reject that null hypothesis, but actually that was true, so this is an error, and this is an error which is we called as type 1 error. So in simple words, what is type 1 error? Where actually the null hypothesis, what you are saying is true, but you rejected that. That is the meaning of a type 1 error. Now consider another scenario where, suppose in actual case, so these two are the actual cases. This is the reality. In actual case, suppose the null hypothesis was false, but you fail to reject that. So at that point of time, that is also an error, which we called as a type 2 error. So there is something which we called as type 1 error, and then there is something which we called as type 2 error. So when we say type 1 error, it is something where actually the null hypothesis is true, but we are rejecting that. That is a straightforward error, which we known as a type 1 error. And another error can be where actually null hypothesis is false, but we fail to reject that. This is known as the type 2 error. So experimentally we will be failed to reject that. Otherwise, the other two situations where actually it is false and we are rejecting that is a correct thing, right? Similarly, when I'm saying that actually the null hypothesis is true and we are failed to reject that null hypothesis, this is also a correct situation. So there is no issue in that. These two are not an error, but these two which I am specifically talking about here is an error. One is called as type 1 error, another one is called as type 2 error. And that is what can be vastly asked in interviews as well, that what is the major difference between type 1 and type 2 error. Here H note is something which I am representing as a null hypothesis. I hope everyone knows that part. So this is another interview question which can be asked from you. Now let's talk about next interview question, question number 18. And the question says that what is the meaning of bias variance trade-off? So what is the meaning of bias variance trade-off? So now let's talk about this. If suppose in an interview you encountered this question, how will you suppose to answer this kind of question? So a model should have, or this is the expectation from the model, that what we want as a final outcome, that there is a model which should have a low bias and somewhere we should want a low variance. Low bias and the low variance is the expectation from any kind of model that we have. That's perfectly fine. Now here if you will see, just try to observe here that whenever I am saying that a model is having a high bias, what does that mean? The simple meaning is that at the time of training itself, the training error is very high. The training error is really, really high. This is something which we are saying as a high bias. Okay, the training error is very high. What does that indicate? It indicates that automatically your model is not able to capture the significant properties or the relationships between the feature. So your model is not able to capture the significant, or you can say the important, I would say, relationships among the features, right? Important relationships among the features that we have. Okay, so this is a kind of a meaning whenever we are saying a model is having a high bias. Automatically bias term is significantly related to the training error. Now when we are saying model is underfitting, this kind of situation will happen where the model is having a high bias and low variance. But whenever we are dealing with a situation which is called as high variance, it simply indicates that at that point of time, model is also, taking the complex properties as well, or I would say the noisy data as well, which I don't want. So model is able to capture the, I would say, complex data or the noisy data which I don't want. And because of this, model is not able to perform pretty well. This is the property which is usually happened when you are saying that your model is overfitted. So at the time of overfitting problem, high variance was there and low bias is there. So there is a high variance and there is a low bias. So usually what happened is that bias and variance both are a part of an error, And in order to decrease down the complete error, we want a low bias and the low variance. Means we don't want my model to be overfitted or underfitted, right? We always want low bias and low variance kind of situation. Now, when you try to decrease the variance, automatically maximum number of times variance will get bias will get increased, and when you decrease the bias, variance will get increased. So there is always a trade off between these two, but we want to take to a point where this kind of situation is happening. This is something which we called as bias versus variance trade off. The second important question which can be asked from you in an interview, question number 19th, is that they can ask from you that the KNN algorithm, which is a part of a supervised machine learning algorithm, can this particular algorithm is suitable for a very huge amount of data? If suppose you are having a huge amount of data, is it advisable to go for KNN kind of algorithm to solve any regression or classification task? So your answer should be straightforward, no. What is the reason behind that? I hope that everyone knows that KNN is a kind of a model which is a lazy learner. What does that mean? That at the time of testing, when you say model.predict, at that point of time, this KNN model will try to find out the distance between the data points that we have, and whatever be the new data point that you have. For example, there is a new data point that you are passing, for which you want to make a prediction that whether it will belongs to class A or class B. So what this particular data point will do, it will try to find out the distance among all other data points that we have inside the model. And at that point of time, for example, if the value of k is equals to 3, so it will look for the top 3 smallest values that we have, and whichever be the probability of belonging to a higher number. For example, you find out that there are 2 data points which belongs to class A and only single one is there which belongs to class B. So it will automatically predict that this new data point will belong to class A. Now all these calculations, which is specifically as a distance measure, which is done by default as with the help of a Euclidean distance, all these things, if you will observe, happened at the time of prediction. Whenever you are adding new data, new calculation will happen. There is nothing called as generalization of a model which is there inside KNN. That's why when you are having a huge amount of data, it's not at all advisable to go for this KNN kind of algorithm. Major reason is this is a lazy learner kind of an algorithm, right? Next interview question which can be asked from you is that, do you know what is the meaning of a kernel trick in an SVM? What is the meaning of a kernel trick in SVM, support vector machine? So you also know that whenever we are talking about a support vector machine, it mainly tries to, I would say, design a hyperplane in such a way it will be able to find out a best fit line which is distinguishing between the two classes that we have, right? That's the major thing that is done by the SVM. Basically, to find a suitable hyperplane, right? Now, the important question here to understand is that whenever we are having some data, for example, I am having this kind of data which is like this, and then there is another data point which is like this. For this kind of data that I have, it's very much almost impossible for me to create a hyperplane in two-dimensional data, in 2D. For example, data is given to as a 2 dimension and data is looking like this. Can you be able to distinguish this data? No, not at all. So at that point of time, kernel trick will play a huge role. what kernel trick says is that what I will do is that I will try to convert this low dimensional data to a high dimensional data. So this is a low dimensional data. Maybe you are having the data in a 2D, okay? And now once it will be able to we will be able to convert it into a 3D. I can't show you by designing 3D, but something like this will happen where you will be easily able to distinguish the green and the red points that we have. The green and the red points that we have. And this is something which is a hyperplane, I would say. So what we did here is that we tried to convert, or this kernel trick tried to convert this low dimensional data into a high dimensional data. Maybe this is a 3D one, right? So basically, what is the purpose of this kernel trick? Kernel trick basically helps the model to find a suitable hyperplane where they will be able to separate the two kind of classes that we have. Sometimes it happens that in a lower dimensional data, it would be very much impossible to take that separate boundary to make that hyperplane. So what usually model does is that it tries to convert that lower dimensional data into a higher dimensional data. And after that, it would be very much easy in a higher dimension data to get that hyperplane, with the help of which we will be able to distinguish between the two classes that we have, right? Okay, coming to the very next question, question number 21, which says that what is the meaning of multicollinearity and how you can measure that and how you can measure this. So the very first thing, whenever we are talking about multicollinearity, the simple meaning is that here we are trying to check that whether the independent features in our data set that we have inside the data, are they having a correlation or not? Are they highly correlated or not? Now you will definitely ask to me, what's the purpose of that? So usually what happened is that it is observed that suppose you will be having the features F1, F2 and so on until there are 10 features that you have, okay? Now when you are having the features from F1 to F10, suppose I am saying, or you have observed that feature F2, F3 and F5, they are highly correlated. So what is the meaning of this? That in a way they are giving us the same information to the model. They are providing the same information to the model, which is basically responsible to make the predictions. Now, if suppose these features are providing the similar kind of information, then what's the purpose of using all these features inside the model? So what we usually do is that we used to find out the multicollinearity. We used to see that whether the features are highly correlated or not. If yes, we try to remove the features and we'll take only the single feature which is giving me the information. So that is the overall purpose of this multicollinearity. How we can measure that? Either you can measure with the help of a correlation matrix, right? Using heat map, you can create that and you can see that whether the features are highly correlated or not. This is a step which you can do in EDA itself, right? And apart from that, what you can do is that there is something called as VIF, variation inflation factor. So with the help of this also, you will be easily able to determine that whether the features are highly correlated or not. The full form is variable inflation factor. Okay, this is the full form of this particular term VIF, whose formula is 1 divided by 1 minus r square, where this r square is exactly the same that we used to study in our linear regression classes. So if the value of r square is high, it simply indicates that the variables are highly correlated. The independent features are highly correlated. Okay, so that is the important inference that you can take from here. So one important thing that you need to understand, what is multicollinearity? It is something where we are trying to see that whether the independent features are highly correlated or not. This is the first thing that you should know. How we can measure that? So for the measurement purpose, we have these two techniques, right? This is basically for the measurement purpose that we have, right? Now, the next important question that can be asked from you is that what is curse of dimensionality? Very important word called as curse of dimensionality. What is the meaning of curse of dimensionality? Usually, we believe that whenever we increase the number of features in our data, whenever we increase the number of dimensions, whenever we used to say dimensions in our machine learning term, it simply means that we are talking about the features here. We are simply talking about the features here. Okay? Now, basically, it simply says that as you keep on increasing the number of features, we usually believe that the model's accuracy will also keep on increasing. So initially, maybe when I'm having a very low number of features, accuracy was very less. But as the time came, it will keep on increasing because I'm increasing the number of features. But what is the curse of dimensionality? It says that after some point of time, when you increase the features, your data, your accuracy will start deteriorating. Maybe this is the point after which you can say that this is the enough features which are required to understand the pattern. After that, when you're increasing the features, somehow, now if you will see, this is the point where the performance starts decreasing, where the accuracy starts decreasing. This is the point where I can say that model starts overfitting. Model starts learning the complex features which are not at all required for the model's prediction. This is something which we called as a curse of dimensionality. That's why we always have to take care of the fact that the features or the dimensions would be enough that my model will be able to understand the important properties. After that, if I will keep on increasing the number of dimensions of the features, model will start decreasing its performance. And that's the important concept behind the curse of dimensionality. The last question which I want to discuss in this series is question number 23. This question says that can you talk about the clustering algorithm measurement, whether it is effective or not? Means the simple question is how you can measure so there is a model evaluation matrix for a supervised machine learning algorithm that everyone is aware about. But suppose you are dealing with the clustering algorithms and you want to see in those clustering algorithms that whether your clusters are effective or not. How will you check that? So in order to check that effectiveness of any clustering algorithm or whether the clusters are effective or not, you can check that using a concept of Silhouette score. Silhouette score, which is the difference between the value of b of x minus a of x divided by maximum value of b of x comma a of x. I will tell you what is the meaning of these terms. Basically, when I'm saying b of x, it is the mean or the average of the distance of the points outside the cluster. Mean or the average of the points outside the clusters that we have. Outside the clusters. And for example, here you are having two clusters. For example, this is cluster number 1, this is cluster number 2. So when I'm saying b of x, I'm measuring so these are the centroids that we have and these are the data points that we have in a cluster, right? So when I'm measuring the distance of this towards this point or this point or this point or this point, This is something which I am saying is B of x. What is A of x? When I'm measuring the distance within the cluster. This is something which I am saying A of x. So A of x is the mean distance or the average distance of all the points within the cluster. Of all the points within the cluster, right? Within the cluster. So now we can clearly see that if the cluster is effective, then obviously the value of B of x should be higher as comparable to the value of A of x. Then only I can say that the clusters are highly effective clusters. Then only we can say that the clusters are highly effective, right? So majorly here, if you will understand, this score value will lie from -1 to +1. And when the value is nearby +1, it means that your score is very good. It means that your clusters are very good. If the value is near to -1, it means that somehow when it will become negative, when the value of A of x is somehow greater as comparable to value of B of x, it means that the clusters are very bad clusters, right? So at that point of time, your value will be near to -1. So that is what we don't want that, right? So this is the way to measure the effectiveness of any clustering algorithm. So I hope that whatsoever interview questions I have covered up so far is pretty much clear to everyone, and I hope that everyone enjoyed this series. With this, I would like to end this particular session. Coming towards the next interview question that I want to discuss in this particular series, that is the question number 24th. So here, this question says that they can ask from you that what is the meaning of a data leakage? Okay, so there is something called as data leakage in machine learning. What is the meaning of that? So whenever this term data leakage is coming into picture, the simple meaning is that usually what happened, this is the very quite frequent, I would say, problem whenever we are dealing with the real-time projects, industry projects. Here usually what happened is that for example, you trained your model, right? And at the time of training, everything is going good. After that, when you test your model on the test data also, your score is very, very good. Maybe you are measuring with the help of accuracy. It is going far good. But when you move that particular saved models or the model thing towards the deployment side, it shows a random, I would say, degraded or random, I would say the accuracy would go down. So that's quite a shocking thing initially. Why? Because at the time of training, model is performing well. When you do the splitting of training and testing, so at the time of testing as well, you are getting a very good accuracy, but at the time of model deployment, accuracy goes down. This is something which we called as a data leakage. Okay, there are various factors which involved in data leakage. The most important factor is that when you split your data set at the time of training purpose into training and testing purpose, right? Training and testing, we usually split, right? By default, this ratio is in 80:20, right? But here, if you will try to observe, whenever we try to split our data into training and testing, the normal cause of this data leakage is that some part of this training data is going towards this testing portion, and some part of this testing set is going towards the training portion. Meaning, some amount of information flow is there. And that's where this data leakage problem is happening. And that's where we are getting the training accuracy as well as the testing accuracy as a good result, which shows that after doing the model deployment also, we will be able to get a better result. But that's not the scenario, right? Usually, one example I can give you, for example, you will be having a train file. Okay, you will be having a train.csv file to train the data. You will be having a test.csv file to suppose test the data. Now what you did is that you merge these two files, and then you are trying to maybe do the data imputation via mean, median, or mode, anything, right? But what you are doing is that you are doing a data imputation after merging of them. But usually the case should be that you are finding out the mean separately for the train.csv file while doing the data imputation, and you are finding out separately the mean for a test.csv file while doing the data imputation. So this can also cause a problem of data leakage, because somehow you are transferring the information flow towards both of the sides. That's the issue in case of a data leakage. So this is one of the interview problem which can be asked from you, right? The next question, which is the last question in our series, question number 25, is that why in case of a sample variance, there is a division by n minus 1. There is a division by n minus 1. So let's try to understand this. In order to understand this part, first of all, we should understand what is population. So complete bundle of, I would say, the data that you have is the population, and a subset of that is something which we called as a sample of that. Can I say? Now, what's the purpose of this sample? When the population size is too huge, at that point of time, obviously I can't do the analysis on the population. And if I will do also, so it requires a lot of resources. Can I say? So at that point of time, what we can do is that we can take a sample out of this population, we'll do the analysis on that, and whatsoever conclusions we have made, we usually assume that these conclusions are equally valid for the complete population as well, right? That's the real agenda to calculate the sample mean or the sample variance. So when we talk about a population mean, suppose we will be having a size of the complete population is capital N. Okay? And the sample size that we picked up is something which is equals to small n. So for sure I am saying that the value of small n is very, very less as comparable to the value of capital N, because it's a subset, right? Now when we are talking about a sample mean, in that real scenario, so first of all let's talk about the population mean. So when we are talking about a population mean, what is the formula to calculate that? First of all, we can simply represent that with the mu. So it will be x1 plus x2 until the value of all the data points, which is capital N, divided by n. So in other words, it's just the average. Now when we are taking a sample mean, which is represented by x bar, so sample mean is something which you can say is x1, x2 until the value of x small n. Can we say? Divided by the value of small n here. So we can easily able to calculate what is the population mean and what is the sample mean. And whatsoever be the value of sample mean we will be able to get, that sample mean value somehow is giving us the inference for the population mean. Can we say? Let's talk about the population variance now. So when we talk about the variance, so population variance is something which is equals to 1 by capital N summation of I equals to 1 to capital N, the value of xi minus the value of mu whole square. So here what we are doing is that mainly we are trying to get the difference between the value of the mean and the feature point that we have. Can I say? Variance, how and what amount of data is varied with respect to the mean. This is the reference which is giving to us. Now when we move towards the sample variance, at that point of time the value will become 1 divided by n minus 1, where small n is again the sample size. Summation of I is equals to 1 to n, the value of xi minus the value of x bar whole square. This is something which we called as sample variance. Correct? Now question says why there is a division by n minus 1. So this is something which is called as Basel's correction as well. So the real objective here is that if you will try to understand the intuition, when we are doing a division by n minus 1, somehow we are reducing the denominator. And when we are reducing the denominator, can I say somehow I am increasing the sample variance? So that the value that we are getting as a sample variance will be approximately equivalent to the value of the population variance. So when we are doing a division by n minus 1, it's a unbiased estimator. It's a unbiased estimator of the population variance. That's why there is a division by minus 1. If suppose we are doing like this, 1 by n summation of I is equals to 1 to n, the difference between the value of xi minus x bar whole square, at that point of time it is somewhere giving us a biased estimator, means the results that we are getting for a sample variance is not giving us a true approximation for the population variance. And that's the major reason behind that. So I hope that I am making sense to everyone. With this, I would like to end this interview series that we have covered up so far. I hope that you really enjoyed this series and you will be able to get the understanding of what kind of questions usually an interviewer can expect from you in an interview with respect to machine learning, right?
So now I hope that you really have enjoyed this complete video. I know it's a bit long video, but I think it's completely worth it because these kind of questions are very widely asked in interviews, and in future if you're going for any interview, you will observe that there are questions which I already have covered up and how basically you will be able to answer these kind of questions. Because you have watched this video, you're already aware about this fact, right? So I really wish that this will be really helpful for you all, and if it is, please do mention in the comment section as well that whether you have already faced these questions in an interview or whether you will be able to face these questions in an interview or not. Apart from this, do share this video with each and everyone. Hashtag good karma, right? Because these kind of content takes a lot of effort from my side, a lot of editing is required, and if you will share these videos, it will really feel very good to me. It will really feel that okay, I am doing a good task with respect to the videos as well, with respect to delivering the content as well. So please make sure that you will do this kind of things, and you can tag me on LinkedIn also. So with this, let's end today's video. I will see you all very soon in the upcoming videos where we will discuss further interesting topics with respect to DS and data science. Bye bye everyone, and see ya.